right. I'll just ping people. So, sorry. Let's see. Welcome to yet another compiler development stream. Now, I'm not sure what I should do today. One of the things that is missing is sorry, is this thing where you take a compile time something and do this. So increment and also these are missing. I did this last stream I think, but this part is still missing. So we could look at that. What other possibilities do we have? Don't have any bugs to fix. All those are already there. Let's see here. I'm looking at the. Maybe we could make sure that fmodf release the pull request is okay. Maybe we can pull that one in. So kind of depends on what people want to see. Well, I'll begin with the pull request. See if we can do something about that one. And please, let's see if we can do this. No, that was wrong. Test runner, can we close that one? Yes, we can. So we want to take this one, the fmod one, and damn, I don't want JetBrains assistant. No, okay. And I seem to recall that this one actually contains too much stuff. So I'm going to check that one out. Let me know if the volume is okay, if you can't hear or anything. So we're going to go in here and we see there's this fmod thing here, this new one, I think. Oh, I just see this diff. Oh, it's further down here. So this is the addition here. So fmod f. It's a weak and it's a no strip. Yes, that's correct. But we got a lot of other things here as well. So we got this printenv thing that shouldn't be in here. And let's see, what else did we get? We got like some changes to that and also main. Right. So these should not be in. Oh, this could be reverted. So let's maybe I'll put this on a new branch or something. I don't know. I think it's easier for me to have this and put it on a new branch. So the new branch is going to be like fmod f wasm or something. Okay. Now this contains everything else, so we can do a. I'm not good at Git, so I used Git the simplest way I know. So what I'll do now is to take what we have and then rebase that on master. And we have like this and that. Okay, there are two different ones. So actually I could just, this should just be removed, right? And we can like, can I just pick this one or something? So I don't want this. Maybe I can drop that one. Okay, maybe maybe this works. So let's see what we got here. So if I just would push this, if I just compare this to now to master, I think I need to mark it. There are the context menus are somewhat strange sometimes. So I'm going to compare this. I don't think you see this comparison unless I dock it. So hang on. Okay, let's see if it's inline. No, it's not inline. So you don't see this diff that I'm viewing right now. But it doesn't matter. It's the fmod one. So the only thing I really need to check is to see if it runs if I just do if I just compile for Wasm. So that's what I'm going to do. So I'm just going to run compile it for Wasm and see what happens. Okay, something broke. So let's see. No module named ABC. Okay, so maybe I just okay. This one. I need main as well. Right, and now let's see here. Okay, something broke or something was a problem. So, oh no, that's fine. That's fine. That's completely fine. So, it looks like it compiles. Um, Now I don't have a good environment to do the Wasm compilation for. So I'm just going to accept this as is, somewhat bravely and foolishly. But I think it's probably okay, and we will have to figure it out if it's not. I wonder about the naming though. Let's see here if everything else is like in the same kind of name. So we have this, and we have nomad. Yeah, they're the same. So that looks good. Oh, I think it was just like a fixing that for float. Yeah. Okay. So now we are ready. I can actually do this and just go to master and check out master, get the latest, which I should have, and then I could just merge this stuff to master. So like that, and then I can add some release notes maybe. So what's that? Maybe there is one. No. Something like that. And okay, so now that one should go into the same. Okay, we're going to maybe do like this. And we're going to push this thing. Yes. Okay, that was maybe a bit anticlimactic. That should make it work. And I'm just going in here now in the pull request, and I'm going to say that just that I've already added this. So okay, and then I close that pull request. All right, what's next? Looking through the issues, that would probably close the fmod f thing. So I'm adding a milestone now. You can see this, but I'm adding a comment, and I'm going through, you know, the different issues. Maybe I should just share my screen. That's better. So hang on. So going to do some magic here and actually share my screen. Okay, I'm gonna get another screen capture, and that one's going to be a window capture for Safari. Right. Now let's see. Are you seeing this now? Right. Hi. By the way, hi. So I think you're seeing this screen now with the issues now. Let's see if I can resize that a little bit so it matches what you see. Right. Something like that. So let me, yeah, you're seeing the screen. So now I'm using, it's light, you have to kind of accept that. We have a lot of fixed things. We have the fault with values. There's a discussion, need additional information. There's this, but it's actually missing some things. So we have this C1 and this kind of this extra work. There's a discussion there. There's a request for something in the macro body. If you open that one, it's, let's see here. There's this workaround for it, and we should probably add a discussion label to that one. More additional info needed. And what's more, there's this old thing about the better prefix. There's some things here. There's the optional thing, print n with this request. There's a pull request for that. Here's something not null check. Was that? Yeah, it's because the ref parameter is going to go away. It's going to go away. So let's deal with that after 0.7. So defer attributes, inline enum values. Do you want to implement this today? So this is quite possible, but it will take some time to do. So anyone, if someone wants to see this, I can do this. Otherwise, I'm just going to go for going back and kind of fixing the last part with this C plus this here. So how do I show this? Yeah. So we have this this case of this kind of situation where you have define a variable like C here, and you might have something like that, and then you want to have, or it's maybe a slice, and then you want to have this code working, right? And you want to have this code working. Oh, the IDE crashed, or an error occurred. Okay, anyway, so this is where you want this to work, but it doesn't. So maybe I can do this. I'm a master, right? So let's see. I know where it is. So we have the ink deck. So we have the ink somewhere. Sema ink something. Ink deck. Maybe ink. Why are there so many hits? Okay. City ink decks. Then detect. This is not it, but it's almost the one. So, right. Okay. So if I already made like a city. If it's a subscript, then we want to do this too. There's a to do here. Yeah. So if I run this, I think we hit the to do. Right. Boom. The to do is hit. Okay. So what we need to do here then it's kind of first we want to have the value from that subscript, right? So we want to make a copy of the inner part. So let's see, it's the inner, right? So and then we want to resolve that. So expr, I think like const cost should do it. If not, hello, I want code completion. Const. I haven't run. Oh, cast const that one. So if not this, then return. That should always work. Like that shouldn't break. Unusual. So let's just put the to do here. I think this is correct. I don't remember if the Simacost const will do this. Maybe it's just the R value which will do this instead. So let's just see what we reach. Either way, we can reach the unreachable or the to do. And we reach the unreachable. Okay, so oh wait, the cost const, it was unhappy with us. So here, oh, it's an unresolved expression, right? So let's see what value actually is. I don't know at this point in time. It's yes, it's a CT subscript, right? So we need to do a expression. So okay, write this. So if not sema cost r value, then we return false, right? So we fail to kind of turn this one into an r value. And we need the context as well. And then we hit it to do. That should be correct. And now it fails because something cost r value doesn't match. Okay, mutate. So what? What does it mean mutate? Okay, so all right. So there's a it's a way where you can like avoid. Hang on. All right, for a short guide, I think this is not needed. This is like wrong now, but there's a way to cast the R value without actually casting it. So you can decide if you want to mutate it or not. In this case, we want to mutate it because we want to turn it into a value. But I'm not sure this is enough, to be honest. Okay, we're ready to do. That's good. That's good. That's good. Now we're done here. Okay, so we will have a value in there. In this case, there should be a 1 or a 2. Let's see. What is the value of the value? No, it's still a CT subscript. That's not what we want. Okay. How did I fold this one? How do I fold this one? Okay, it's a pure, it's an address, it's a runtime content, blah blah blah. You shouldn't have that one. Because it's kind of a subscript, and it will have the index. Shouldn't that somehow be folded by something? Right? What can we do about this? Like, yeah, I guess we could take and do this manually. So that is a bit annoying. That is a bit annoying. Like, okay. So because we have a subscript, we know what the type, the parts are in there. More explicitly, it's like we have a CT subscript expression which has a declaration. Okay, that's a variable, and we can actually take that init expression or var something init something. Let's see here. So actually we can then do a less of a copy. So the declaration, and then it's going to be the var, and then it's going to be like init expression there. So there's the init, and that's going to be like a some kind of constant, and then we're going to make a copy of this because we're going to do bad stuff to it. So the copy is going to be and now we have a copy, and then we can do whatever we want. So in this case, we can send it at, so init, I think like there should be a way to fold this. So at something, let me see if I can find that. No. So we get to go back where we create one of these, and then we're going to see where we find this thing when it's constant, fold this. Okay, not the L value. We want to analyze subscript. Oh, there's an index here, so let's go for that one. Oh, this is the one, right? So here we go. Resolve subscript index. And then we get overloads. We are not interested in that. If the constant, then we get la la la. And then finally, okay, the index is constant. Okay, yeah, this is just solving the index itself. Okay, so let's see where it's used. It's used in subscript. So we'll do that, and then it's an untyped list. We're going to get that part. Otherwise, we find the blah blah blah. So we have somewhere here, like if it's a constant, where do we get that? So here, if it's a constant, it's kind of looking at the index in here, and it's out of range. Okay, so here we have subscript rewrite index const list. This is the one we want. So I knew it was somewhere, I think. Okay, so let's go back to whatever. Yeah, this is where we were. So we want to do this. Like there are two cases. So one is that it's this kind of this thing here, this copy could be, well, it must be a constant, right? So it must be const expr, and then the const kind, and then we can actually we can actually use the init for now. Or do can no we do the copy. So cases, there are a lot of cases, and let's say we don't have any cases, then we can generate them. I think case const in r then we generate the rest of them. So the float integers, they are not indexable. Enums not, bytes are, and a string is yes. The pointer isn't, nor the type ID, but the slice is. And these are going to be a little different. The ref and member is not. So in the case of a const, right, this is going to be like annoying because now, since we know this, like it's an increment or decrement or whatever, we're still, if it's like let's see here, do we get what's actual, if it actually is an increment or decrement? So no. Okay, so expression I'm going to say, okay, so we are going to have to do some copying here. No, we're just going to get, okay, so we're just going to get that particular value, right? So maybe we can go do a helper. What's that going to give us then? We're going to have this add for different things, so we have to make it a bit generic, I think. Maybe. Okay, let's write the code first. So in this case, we already have a copy, but it's rarely that the copy is actually copying the internals. So this case, we actually have to make a copy of that thing, but we already have something that can do that. So we're just going to get the element. So in here, we just go to copy const, right? Copy this, like the machine learning is trying to come up with ideas. So we want the const expr, we want the bytes, and then we want the pointer, and then we want whatever the index was, and it was something like, yeah, let's get that index. So we're going to get that index. Oops. And actually this time we didn't need the copyright. The copy. So maybe we don't do this copy unless we need that. Okay. So here, now we get the particular byte. So I need to go in here, create some kind of, now, okay, CLion just froze there. I didn't like to do the indentation. I don't like the indentation here either. CLion, it's too much, but okay. So we want this character here. So this one is going to be init and this kind of thing. And index, right? That's going to be the value, and then we have if the f like c equals c plus is f expression and was a unary expression, and it was the operator equals operation unary op tick. In that case, we do a c minus minus. Otherwise, we do a c plus plus. Right, and now we have the new value. So we can, here we can do a Sima expression replace something something. There is something expression const, okay, const init rewrite array at, yes. But hang on, this is just for arrays, right? So this is not doing the bytes. So there is a problem here because these bytes might be from somewhere else. So we have this assign here, and it's going to be like doing this, right? This whole thing. So let's see here. Let's do like this. So we're going to do this, you know, yeah, let's copy it. For now, we're going to see that we're going to get one more of these. So it's kind of annoying. Okay, so we want to have the same. We want to have the bytes. We're going to do. Oh, they kind of got this const. Maybe this is a good idea. So we can do like expr const equals init const exp. This is just convenient to kind of shorten what we are using all the time. So expr con or const. That should be const. Expr const. Okay, and the const kind is then just like this. And then we have, now this works. So expr const is like that. And we don't have write, we just have, you know, we have this copy. And this is not there. And we're going to change that in the copy. We're going to change, you know, this new C. And then we're going to change, you know, copy this thing back. And then we're done actually, because we already, and then can, you know, expression replace, you know, this whole thing with this value, right? And it's going to be like, is it the value before or not? That's the question. So we can do it like if it's, if the expression kind is okay, let's do like maybe like this. So if it's a decal, then we do copy equals -1, expression replace, okay, expression rewrite. Const rewrite. So it's going to be a const int of the expression to what type? Indexed. We're going to get the index type here as well. Type indexed is going to be type get index type. Index type of whatever the type was of the inner type. So the inner type. When the AI is actually giving me a good suggestion, I don't have any mapping to select that. Okay, so now we can do like this. We want to have the type. Okay, so this in the index type. Index, that's going to be like sorry, signed or unsigned. And then we're going to take like, okay, it's okay, we're going to have like post and so bool post equals expression expression kind equals expression post unary. So, and we can check also the deck. So bool tick equals this part here. So if deck and so if it's not post, hang on, if it's not, so it's a pre. If it's a pre, then we're going to rewrite, if it's pre, then we rewrite I think I probably have to restart CLand because it's like really acting weird now. So, okay, if it's a pre, hang on. If it's a pre, we can always take. It's going to be like the same. If it's pre, then we gonna do this, right? We're just gonna rewrite the expr into a const expr. So, and then we have the change, right? So we're gonna do C is going to be like this, right? And we're gonna have then that part. There we go. We're going to take like C here. And then if it's not pre, then we're going to rewrite it. If it's not pre, rewrite it with C. And then we're done. We can return true. Okay, and then for the rest of them, that's what to do. Okay, so we got one of them. Let me look at any comments here. So, is it possible to name a little warning in CLI for when a macro is defined but not used anywhere in the code? Right. Are you talking about like for C or for C3? For C, it's it's like there are inspections for that. How helpful is AI when writing C? It can kind of predict stuff. When I don't use the full AI thing, I just I didn't disable the completion, but usually the completion is like halfway right, and it's like really annoying to just not being able to say that just pick this part. But I'll restart this. Let's go back. I'm just going to switch you over to see this, and then I'm going to restart Sea Lion because Sea Lion is bad. Yeah, I mean, actually I like IntelliJ's products a lot, but um, they also crash. It's not as bad as um, um, Xcode. Actually, Xcode is crashing so much for me, and that it's the worst thing is like it's crashing when I do UI editing, and that's not nice. So see here. Okay, I got the screen, so let's switch that one. Right. Okay, so we almost like it's almost correct that part. But we have errors here now. Suddenly everything has errors. Why? Okay, so I must have done something wrong. I must have forgotten some end. Yes, this end. Right now it looks happy again. Okay, so let's test this. Well, the only thing that will work now is like having a string or something. So let's have a string, right? And we have it called so ABC, ABC, right? And now we take this one and then we're going to print it. And we can print before and after, by the way. We can print before and after. So like that, and let's see if it does the right thing or if it crashes or say it says something it's not implemented. Oh, it says it isn't. Okay, the index type doesn't exist. Okay, because the inner type, let's see here. Oh, wait, it's not the inner type. I want this init, right? So the init. Yeah, I want the init type, right? Because we are subscripting it, right? So otherwise it's not right. Okay, let's see. No. Okay, did we update things? Oh, wait, we didn't do that. So what we're going to do is we forgot one more thing here. It's the we got this thing here from that one. We're not going to have to update it with the copy, and I don't think we did that. So afterwards, we're gonna update the copy, update the thing with the copy. So right here we got the copy is there. Now let's see. Oh, unhappy because the pointer is const char, right? And this one is unsigned char. Oh, whatever. Let's just do that. Okay, so we got ABC and then got ACC. Okay. Okay. And okay, we can do like this A, B, C, D, right? And then we can do A, C, and then we do right. And let's see that this works. Maybe we can print the parts in between, right? So we should get the old values, like the characters before the change here. So in this case, we get the before. So we should get BCD here. BCD, let's see. So we got no, we didn't get this. So we are getting the post one, the other one. So let's see, did I mess up things here? So the pre is going to get the C directly, right? And is it pre? So it shouldn't. Oh wait. So I'm doing this wrong. So post, right? So post, and that's the one we're going to test for. Now, being extremely stupid here. Post. So in the post case, we do it before. Otherwise, we do it after. Now it should look better. So A, B, C, D, yes, just like we wanted it. And then we can, we can take the same, another string, like that, and then we can do it again. So we call this D, but now we're doing it before instead. So that should yield, yeah, CDC, yes, ACDC. So okay, we got that to work. But that's just a start. Like the last time, this is going to be like, okay, I'm going to need to do this for every single thing. So now there's a slice. There's one case where the slice is empty. And I'm pretty sure that that's handled. Let me test that. So that it gets me an error message before everything. So let's say I have something like this, right? An E, right? And then I say, okay, let's do, this. Is this an error message or not? Yeah, it's an error message is outraged. Good. And I should get the same thing if I have something like this, right? So again, this is a slice, and it's yeah, index out of range. So we're fine. We can know now that this is just these two will do the same thing. So we have the untyped list. The untyped list is a little tricky, but ultimately might be able to do that the same way. So we are we're gonna get what's in there. Do we know that that thing is addable? Let's see if that check is done before. So let's pick something that isn't, that you can't add, right? So we can do something like this now, and then we try to increment that. What happens then? Do we reach it to do? In that case, we need to test things. Right, we reached it to do. So we don't know that the thing we want to update is actually going to be increment, possible to increment. And now I think like the best way of doing this now is probably to go for a more general solution that we can use later. At least this should be out of there, right? Inline bool sema exp analyze ct ct subscript inc deck, and then we have to do the same thing. You want that again. This is why I didn't do it immediately, because I knew this is going to be like something of a pain. And we're going to do like return sema analyze. This is like so long. Subscript index and context exp inner, right? Okay, now we can pull this out of there. See, we have some of this information already. Like here, we already know that we're gonna want to do this. Hang on. You kidding me? Oh, wait. This is just allowed on ints, right? Right, right, right. Right. All right, that's good. That's good. That simplifies the work for us. Again, sorry, I have to run away and kind of close the door. Okay, but this is going to be easy then. Okay, so I am. What I'm going to do is basically first. Now in this case, so I'm going to get like go for the various cases here. So first of all, we're going to exclude these cases, right? The ones that we know should never happen. So here I can just, I think, make them go away. Like, yeah, so these can never happen. So we make an unreachable there. Then we have the case which we already saw with like this bytes and const string, and they are solved in the same way, and that's like pretty simple, right? It's just it's a special solution for that. But for the rest, I'm not like I don't want to do that inside of a switch case. But what I can do is kind of extract this the constant, so expr value, which is the one I'm going to extract. So in the case of an untyped list, we can just we just going to do like the expr here is going to be the value is going to be the init. Oh, did we? Hang on, did I did take the const expr const, right? This should be expr const too. Expr const, and this should be the expr const. All right. And so such and a pointer. Okay. So in this case, we have an untyped list. This means that we have this, and then we have untyped list, and it's going to be like this index in there, and that's all. If it's a slice or initializer, then it's a bit complicated, but the value is going to be given by const init at, no, not right, value. Okay, this is maybe not what I want. So let's see here. Let's say rewrite to const initializer index. So here's the one, initializer for index. There is something like that. So okay, there's a way to get that, but okay, so let's see what that is. So this is a static inline thing for expressions. Okay, but do we want to rewrite something to the const initializer index? Okay, maybe we want to rewrite, you know, we can kind of rewrite. Actually, you can use this one. Okay, it's going to be more efficient, actually. So we're going to take the expression. We're going to, oh, if not expression right and blah, 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 index, and it's going to be like the list type is going to be no, the inner, not the inner value. It's going to be like the expr const type. Oh, sorry. The what was it? Yeah, okay. Sorry, the init type, and then we're going to grab the this is kind of funny. This is going to be similar. So we're going to grab the list, which is going to be expr const initializer, and then we're going to take the result, which we can put in the expression, which we can overwrite that one, and then we are taking the unsigned index to which was the index that we had, and then it's not from the back. Okay, so we're going to do the false, and if there's an error there, we return false. Oh, so okay, so like this. So now we put that in actually in. We're going to say like a value is equals the expression and then we're going to use that one to rewrite. Or should we rewrite the maybe we should rewrite the init itself. If we already have the variable, but we don't have that. Well, we do have the expression that does. Okay, so we can use init. We can use init if we want to. Just trying to see where I can. Okay, maybe I can just have a temp. Right, we can just make temp like this, and then we do is equals to temp, and then we rewrite and use temp. Use value. Okay, so that would work. In this case, it's not initializer; it's a slice init. Okay, and then we break. Right. So now we have only the case where. Where did that end? So there's that. Why is it? Okay, so now we only have something in the value, which is the actual thing. So f is constant. If it's not constant, then we're not. Okay. Then we're going to send the variable. No. The expression compile time script the index type is not an integer, and then we're going to have the expression itself. Now, sorry. We have to have an emergency at my family. I think. Hang on, folks. I'll be back soon. Back. Suddenly, oh, is my mic extremely low? Okay, let me try to increase it a bit. Maybe you hear more. Let me know if that got better. Okay. Let me see. In older version of CLI, I was able to get a warning on Dennis macros, but in new version, it seems to have stopped working. I don't know. I can just check that. So if I would then do a define foo, right? No, it doesn't seem to do anything. Maybe there's a problem. Okay, I'll let me continue here though. Not all control paths are, yeah, no, there's no return and everything. So here it's not a constant. Do I forget some break somewhere? No, I don't think so. If it's not an integer, now let's see what happens. So if it is an integer, then we're going to make the change. Here's this code. So we're just going to do this thing, right? And let's see here. So do I make a copy of that as well? Yeah, they're making a copy. I don't know. Maybe I should do that. So, okay, we are making a copy of this value. But we already copied this. We did rewrite this one from somewhere else. And was that doing a copy as well? No, that was replacing. So let's be sure, and then we're going to make a copy of this value, right? No, we don't need it. So let's say that the value is a copy of value. So now we're done. There. And now we can then say if it's a deck, then our value. Oh, we need the old one. So maybe we're gonna need the new one. Hang on. So if it's post, and if it's post, then we want to first make a copy, right? We want to overwrite the current expression. So we're going to do a yeah, we are going to rewrite this one. Okay, so if it's a post, then we are going to first make a copy and replace. So we're going to replace the whole this expression with the value, right? And then we need to take a copy of the value, right? Like that. We are going to need to take a copy of the value anyway, but okay, so but we don't need to do anything weird, so this is going to be fine. Because we're replacing in our place, we're going to just replacing the stuff inside. So okay, so this is good. We are replacing it, we're making a copy, and now we're taking the value, and then we're going to just change that to whatever new value it is, right? And then we are going to, if it's not passed, then we are going to rewrite again this thing with the value, and then we're also going to replace this value inside of that particular thing. So now that is something else. So let's see here, expression assign ct subscript assign. So now we go into this one, right? See what it does. So here is where we do that, and then we do a constant rewrite array at, right? So now we are going to do that. So we already have these functions that do some of the stuff that we want. So again, we're going to switch. Okay, so we're going to switch again. Because I wanted this common part, that's why I do switching twice. So here we go. And now we're just going to have the in the case of const untyped list. Then it's simple. We're just going to this into this list, this untyped list, and then we go to the index, and then we're going to set it to the value, which then might be a maybe not ideal. Maybe we have to create this anyway. New well, we don't want to create this if we have one of these cases. So it's just here. So value darn. I guess we're gonna have to make a copy regardless. Okay. So in the post case, let's see here. So in the hang on, I'm just going to have my kid here asking questions. What's being worked on? Oh, sorry, the microphone just hit the limiter. What's being worked on? Well, it's compile time, increment, and decrement, basically. Okay, so right, so let's see here. And thank you for confirming that it's better now. So okay, expression copy. This is going to make a copy of the value. That's going to be fine. So we make the copy. We do the expression replace. But then we might need to make another copy here for this change that we do, and then we replace it with the value. But now, so now we're fine. We can do this, and we can put in the value because it's not now fine there. We have the case of a const const slice. So in that case, we do a const init at rewrite array at something. I think that was it, right? So we're going to take the expression was that? So it's the expression const slice init. That's the init, and the value is going to be the value, and then we're going to index is going to be the index, right? It's like that. Otherwise, it's the case of a const initializer. We do the same thing, but with the initializer, and then we're done. And the rest of them should be unreachable. And once we're done with that, now we should have rewritten everything, right? So we do rewrite everything. So then we're done. Let's test this. Just compiles. Oh wait, did I have 05 to turn on? That was a bit overly enthusiastic in terms of optimization. Okay, so the index type is not okay. Yeah, that's fine. And let's just put that like that, right? And then we can print it maybe. Maybe it's in this case we have to cast it to int, or it will be unhappy, right? Because it's it might be an untyped list there. And then we do the adding, the increments like that, right? And then finally here we're gonna check the same thing. So it's gonna be the E, not a D. Like that. Let's see. Oh, why did I put C there? So that worked, and that was a untyped list, I believe. So let's do the same thing with like a slice. Okay, let's confirm that we're actually hitting this part of the code. Yeah, we're doing that. Okay. Maybe we could print the value as well as we go along. So we're going to print this one like that. And we should get a 2 there, I think. And the next one after, oh, sorry, we have 2 of them. So let's print the first one. Okay, and the second one is going to be an F here. And we're going to have a slice, I think. And we don't need the costs. And change. Right, same thing. And now with slices. And that didn't work. Right? It didn't increase it. So let's see why. Okay, so we got. Okay, we did rewrite this one, the constant slice, but something didn't quite work. Why? That's strange. Okay, let's debug it a bit. So we're going to go here, right? So we are getting here. We are going to post, make a copy, and then we make a copy of the value as it is and put that in value. That shouldn't be necessary because this is going to be an integer, right? So we don't need to do that copy actually. Let's not do that copy because this is just going to copy over the contents, and this thing is by value anyway, so this should be fine. Okay, now let's go. So go in here. Oh, this is going to be the second. This is going to be after this first time. And now we go in here. We go and do the ink, right? And then it's not a post, and I'll go here and go into the slice. I'm going to replace the value, and let's see that the value is now whatever that is. It's going to be like the const expression, and it should be 3. Going down and drilling down here. It's a 3, right? So we're going to replace that slice init in there. I mean, go in here, it's not, it's going to, we're going to flatten that particular thing, and then we're going to update the slice, and then we're going to write that with the value. Right, that looks fine to me, to be honest. So I'm not sure why that didn't work. Did I update something else or something? Look at the code again. So, okay, let's say this didn't work, right? What happens if we do like this instead? Now this is instead this other. Oh, no, that didn't work either. Curses. Why didn't that work? For the untyped list, it was like worked perfectly, but does this return anything? I know it just mutates that const in it. It does mutate it. This looks fine. This looks fine. I don't really understand why that would fail. So the index again is 1, right? We go in there. We find somewhere we want to update it. Oh, wait. What's this? This looks right, but clearly isn't. Okay, wait. This is assuming that this is broken. This can't work. Because if here we are going to be basically assert that const init kind equals const init array. Sorry about that. And I just can't see that this is, because this one is assuming that. It's not that this is harder, it's just that it seems to be assuming things that just are incorrect. Right? And I go in here. Yes, it fails that one. So actually, in this case, we can go to init array full and index. Like, oh wait, we can do like this. Oh, if constant is equal to init array full, then we do like this. Else we go into this one, and then it's a bit more complicated, but we still get that inner value. We write it to this value, and then we're done, right? Okay, now that was a pretty bad error. Now let's see if this works. Boom. So we actually found a bug in the subs, this rewrite, actually. So yeah, that was the simple Inkdeck thing. So then we had add, but I don't think I'll do that today. It's just, I'm going to, leave this here. I'm just going to make some more tests. So we have this case, right? We have F. Let's see, IAG. And now we're going to do it the other way around, right? So like that. And then we're going to do, we're going to mutate the other thing here to 0, and then we're going to print it. Let's just see that that works. So now we expect to get like the value first. So we get like a 1, and then we get a 0, then we get 0, and then we expect to get 0, 1, 3, and that's what we get. So all of this looks okay now. Okay, let's take some questions if people have them. What? Hang on. All right. Let's see if it's. Is it possible to define a function pointer with a specific prototype directly inside of a struct without needing to define the function prototype separately beforehand in C3? Prototype directly inside of a struct without needing to define it. Okay, so I haven't planned that. So I think the question is whether you can create, like, if you have a vtable, right, and you want to have something like this is the question. So if you have this, and then we do want to make a struct, and this is like the fantasy syntax. So you want to have a struct, and you want to have like fn int foo, right? Something like, or like this maybe, foo fn void bar and so on. This kind of thing, instead of having to do like define it. So int function. Oh, crashed again. It's probably the yeah, it's the actually source is null. No idea why. Okay, so anyway, starts eating my yeah. Oh, it's trying to parse this, and then because it's unhappy when I do it like this. Okay, so let's say we have like this, and then we have, having to type this, and people want kind of this thing, right, to be able to do something like that. Yeah, downsides, and I mean, I've thought about that many times, right? If you're just doing some ad hoc stuff, like you're actually, you know, having a list and you want to do them quickly because you don't intend to use them, then it's much nicer to be able to do it in line. I understand that. Um, so, but it's also, as soon as you ever want to use it more than once, you want it like this. So, I don't know. I don't know. It's like there's an upside to it, to being able to do it inline, but it's also a downside in the just the lack of clarity everywhere. Um, and I mean, if you're going to use it, if you're not allowed to use it inline, then I mean, um, you will have to have that alias anyway. So it's not clear what's good. Um, as you might know, C3 is not using vtables for the interfaces. So, and you never do these manual interfaces. So, yeah, this requirement that you had to do like this is that actually comes from C2. Um, yeah, if you file an issue and then have like uh, good arguments for what, why, and also syntax examples showing how it should look like and so on, then yes, it could very well go into the language. Um, but um, I often get like language requests like I want this, and then I kind of ask questions and then kind of leave out the details to be worked out for me, but by me. But the problem is if I'm working out the details, I don't know the use case. I didn't have the use case, so I can't really design a good syntax for something that I'm not doing. So that's an important thing to think about if you want to, have something go into the language. And if it's a major feature, then then actually something else has to go. So then you have to decide, okay, we want to replace that feature. We want to put this feature in, and this is the feature that should go out. That is not valuable enough in C3. So the reason actually that we are getting these, the reason you're getting these, is because we removed the reference macros. That's why. Maybe we wouldn't gotten it otherwise. The reference macros being like reference macro arguments. So being something like this. This. So this is not. This is going away now with that reference, and that makes the macros a bit smaller, and then we can, make this a bit smoother. So if you want to suggest something, feel free to do so. But prepare to put down some serious work in order to, I mean, especially use cases. That's how AI can evaluate something. Like, yes, it does simplify these use cases. Then it's good, right? If it's just like, oh, I like to type a few characters less, but it's not actually more readable or anything, then maybe it's not, or maybe I just thought it up. Like, this sounds like a good idea. Let's propose it for the language. But those ideas are, um, they have to be really worked out and like check that they actually help. Okay. Any other questions? Okay. Oh, I don't know. Oh, wait. Things I just say daily when programming. Yeah, that's normal. Inside a function, you can do var some function but not inside of a struct. Yes, but you can also get like you can always actually you can get like you can do type of, right? You can do type of. If you want to, it's like it's if you're really desperate. I also noticed, by the way, I noticed this the missing that this was kind of missing. So this doing this, like you would expect this to work, right? Because then we can call it later, right? So maybe this will go in. I don't know. But meanwhile, you can do this. This will infer the size, the type correctly. So then you don't need to define it, by the way. But I was also thinking like maybe I should allow this for everything, but you can like do like you have to write infer or something. Because the thing I don't want is like I don't want people to do like this. This is my fear. Like they literally do like this, and you kind of see it too, and you kind of like why, and you start doing like bar is like one bar. Stop, just stop, you know, just keep going. They just keep going, and then you're like, okay, what is this type then? Like, what is this the type of this variable? Oh, that's a string because that's going to be a string, and like, no, 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 no. This is going to be like this is correct, right? This is correct. This is what you want, not the var. But you could allow it if you say like, okay, I really, really need that. Okay, then you can do like, okay, infer or something. And then people won't type this because it's, they won't type it because they're long. It's because they really need it. Because maybe in some cases you really need it. That would be fine. Right. Like if you do like this, for example, like if you do if something something, then int a is something something, else you do like double a something something, and then in that case, like maybe really want something like var b equals a there, and you want to infer the size type. Yeah, in that case, I can definitely understand it. People could like, yeah, I do it because I need it, not because I felt like shortening stuff. Right. So that's an out. Let's see if there are any other questions. Right. So yeah, this will probably be allowed in the future. This one. This should be allowed. The inferring of that the function type, because function types are a bit annoying. That could actually simplify some things. Anything else? Right. Maybe some of you disappeared here. Yeah. So I'm going to leave it like this, I think, because of the increment being, it's kind of a special case. I don't usually I would think this is like too much to do another, having it's separate, but this is kind of special, and it's hard to do very generic. Actually, it just eludes this generic behavior. So the other one is going to be like, okay, we are going into, maybe we can do some simplification. We have this, right? If this is a foo, yeah, we do it like that. And then if it's not, if the kind is, like if inner kind is instead that, then we do return sema subscript context inner, because then we don't need this to handle both of them, and we don't need that. Okay. What else? So that's increment, decrement. What else? What else? We have, yes, the addition. So let's look at the sign, by the way. So it's going to be a sema assign. Assign. Maybe it's just me, but that looks very okay. So we have, here are the op assign, and we have the ct common assign in case it's a ct ident. But then we have the similar thing where it's where we basically have this L value, right? So left sign is what happens now if I do like this. Where is it going to end up? I'm just going to look at this. So we are having something. If you have G, right, we have that one again, and I will say is plus equals 12. That crashes the ID, but let's see what happens. So we're going to end up here. Actually, it's going to be totally broken. Let's see what the left-hand side is. It's a CT subscript. So okay, we can do like this again. Like expression f left expression kind equals expression CT subscript. In that case, return. We know what to do. Right, and I think that is enough for now. Okay, we need some tests, and for now, I'm just going to, since I know this does well. So we have a subscript somewhere. CT subscript, maybe. What's this? This is somewhere. So we're gonna have file CT subscript inc. And then we're going to pick a target. Now just grab macOS x64. We're gonna expect that we have a test ll, and then fill that one with some scrappy crap, and then run this and just see where it takes us. Okay, so meanwhile I'll do the release notes, and the release notes. Okay, release notes, and here we are. And there's already this And I think there is this issue for increment, but it's not all of it. So I prefer to. Actually, that one's just. It should just be. It's a. This one. Right. And I haven't hit this error yet. Let's see if we have any other questions. So, no. Two brave souls still with me. So, we will see here. There we go. There we go. Just grabbing the right thing. Pause that. Stop it actually. And let's copy paste. Now the code is always very messy at 01 whenever we have prints, because we're passing those things and often do things on inline. So the print is very much inline, so it's like this huge thing. So if you do the same with printf, it's like small, very small, but here it's like it's huge. Right, almost done. So I paste the resulting code in here, and then let's see if I can merge this so you can see. I have a window here, so let's see if I can side-by-side viewer, unified viewer. No, that's not what I want. So the problem is here now, you can't see my diff, I think, which means it's kind of boring for you. But what I'm doing is now I'm just cutting down the test a little. Actually, what I want is probably mostly, the strings. Now that I think about it, I don't want the print. That one's useless because it's going to print a bunch of things. So I'm just going to, keep the output of the constants and stuff like that. It's quite crazy, but that's the way it is. So if you look at this file now, we changed a bit. So it's just the constants that I keep. Because, okay, actually I can remove these. Oh, no, not, okay, so those, no, sorry, these are correct. So you see how these are encoded here. So by the way, like if you do a lot of macros, then obviously, at least at the beginning, you'll get a lot of code because of that. Because it will create a lot of AST nodes, copies back and forth. And even if that in the end kind of compiles to something smaller, it's just going to go through a lot of more stuff. But I think that actually it does create more code, right? If you're not thinking about the macros actually doing a copy and you have like huge methods, they all are macros, then things are going to be bad. Macros should be used for small dispatch. You have something, a short function, and it's like it's either polymorphic, you want something polymorphic, or and it's like short polymorphic. If not, if you want something longer, use generic generic modules to create things. It's sort of unwieldy, and I've thought about like making generic macros. They kind of that are not inline, that are function like, but I mean, it's just gonna be like I thought about that, but from the beginning, I was like thinking there would be like three types. So function and generic, and it would be the macros, and the generic would be like a macro, but it would, you know, compile down to a function. So basically a polymorphic function. But I just that just made stuff like it's so overlapping that I didn't want to keep that. Um, just felt there was a lot of complexity to handle that, and you can kind of reproduce that with with um, lambdas, but not so nice. So I could actually leverage the lambda code to make generic functions if I wanted, but I haven't wanted it enough. Okay, so let's copy this one. Or sorry, commit this one. And there it is. How it should work. Um, hopefully, maybe something breaks on some platform or something. But at least the tests are passing. Yes, that's it. Unless anyone has any questions, I'll just say good night and hope everyone has a great weekend. Good night.